Okay, guys. Okay, let me share my screen so that we can get started. Okay, so you guys can see my screen. All right. Okay, guys. Also, please try to admit those who are joining us late. Okay, guys. Without wasting any of your time, the first thing that you have to do when writing your test, right, is to what? Okay, in your computers there at the venue, right? You will go to files and then okay, wait a moment. Okay, so you will go to files and then now when you go to this PC, okay, it will show, but then it will show something here, return post space, right? So you will go there, guys, on post space. Wait, that's where you're gonna save your work. All right. So what you do when you get there, you will have to create a new folder, right? Okay, so let's create a new folder. And then with your name, name, initial name and student number, right? Just like that. So okay, on my side here, it's on desktop, right? But then the computer you'll be using ThoughtSpace. But why ThoughtSpace? It's because even if your computer crashes, you can restart it and then you will still access your work. Unlike when it is saved on desktop, once your computer crashes, you lose your work. So that's why it is best to use ThoughtSpace. Okay, so this folder here, it's where I'll be saving all of my parts, right? Okay. So this one is the first step towards saving your work here. This is the first step that you have to do. All right. Okay. You can also use the chat box, guys. The other tutor is here also. Okay, so now you are done with that, and then now you can open your Inventor software like that. Okay. So now I want to create a new part file, right? Okay. And then what type of a file do you want? You want an IPT file, right? So want a part file and then you create. Okay, let's give it more time, guys. Okay, yeah, so now there you have it. Okay, so as you know that you will be given your assembly like this. And then you guys said that in the test, you are given an assembly that doesn't show the full assembly when all the parts are now assembled. So that's why in this exercise, I only gave you part files so that you guys can figure it out yourselves. That how do you go on about creating now the whole assembly? Because I believe that even in your test too, you'll only be given part files without the assembled drawing. Okay, so you have to figure out how to assemble yourself. Okay, so what I've always told you guys is that you have to always start with the most easiest part, right? Okay, so now looking at this, the bush and the shaft are the most easiest parts here. Okay, but then you guys in the group said that you want me to start with the bracket. Okay, so what time is it now? It's 11 minutes past. So I don't know if ever there are more people that will still be joining us, because I really didn't want to leave anyone behind on this one. So I think what is best we can do is that we can just quickly draw the shaft, so that at least maybe by 20 minutes past we can start with the bracket, because I believe that by that time everyone will have joined the session. Okay, let's come to the shaft. I don't think there's any missing dimension here, because we know that the smaller diameter here, it's M16, right? Sorry, it's M16, it's given. Okay, so we know this one, it's M16, right? Okay, and then we also know that this one it's diameter 24, it's given. And we also know that this one is diameter 19, it's also given. All right, and then we know all our lengths. We know it's 20, it's 32, it's 161, it's 29, and it's 20. Okay, so what is the easiest way to draw this shaft is to use a revolve feature. Okay, so I will go on about that. All right, so since you created your new part file here, you have to save before doing anything, right? You see, I haven't drawn anything, I haven't started a 2D sketch, so you have to save here, right? Save, and then it should show now where do you want to save it. And as I told you guys that you guys are going to use ThoughtSpace and all of that, but then for the sake of this one, I'm using desktop, right? And then there is my folder that I created. Okay, so what is this? It's a shaft, right? Save. Okay. So guys, if there are questions, please unmute yourselves and then you can ask. All right, so now let's start a 2D sketch in the XY plane. There we have it, and then we're going to need a horizontal line, right, which will be our center line, like that, and then make it a center line, right? There we have it. Okay, so now what I will quickly do is I'll just quickly draw the profile of my shaft, but the half section of it, which looks like this, like that, like that, like that, and like that. So there I have it. So now we can extend this center line to meet with that line at the end here. Okay, so now our sketch is closed. Okay, now we can start with your dimensions. We know that this one is diameter 16. And then this one is diameter 19. Have it, and then this one is diameter 24. Okay. So you also have to make sure that this line is in the same straight line with this line, and also this one with this one. So how do you do that? You're going to use the horizontal constraint or the collinear. But you can use the collinear since you want this one to be collinear with this one. Okay, it seems like the constraint already exists. Okay, so I believe they're already collinear. Okay, so now what's next is this dimension. So we know that it's 20, 20, 32, 161, and 2920. Okay, let's go to Inventor. We know that we have 20, and then we have 32, then we have 161. All right, so now you see what is your sketch doing here, right? So you just have to come to this line, just drag it all the way to the end there, and also come to this one and also just drag it like that. Want to drag this one. Yeah, so now our sketch is now okay. All right, so we have 20, we have 32, we have 161, and then we have what? We have 29, and then we also have 20 again. All right. So here we're saying that we have 29, and then we have what? We have 20. All right. Then there is our shaft looking like that. So now, as you can see that our shaft is chamfered here and also here and there, right? And also it's filleted here in this section. It's filleted and also there. Okay, so now go back here. Now you want to what? You want to chamfer. Chamfer. We can use 1,5 because it was not provided, so you can just use any. So there you have your chamfer, and also you have it that side. Okay. So now what more else do you need? Okay, something happened with our sketch. We don't need this line here, right? So and I want to remove this line. We don't want it. Okay. And also this portion here, we don't want it, right? Okay. So now there's a problem here. The 20 moved, so we just have to delete this one because the 20 it's from here to there. Sorry, it's from here to here. There. Okay, we have it. Okay, the side we're fine, and then now we also need to apply a fillet. We can use 2, it's fine. There you have it. Oh, it's too big. Okay, let's undo. You can use 1, right? So there you have your fillet, and also there you have your fillet. Right. So now you are done with your shaft like that. So now you just have to finish your sketch and then revolve. And then you select your profile like that. And then you also, okay, it's selected automatically the revolve axis. Okay. And then you click on OK. So there you have your shaft looking like that. So now let's come back here. What more else do we need in this shaft? Okay, we're told that it's M16 by 2, meaning that the depth of the threads there, not the depth, guys, the pitch of our threads, it's 2 here, it's given. Okay. So okay, sorry. So now we also know that the depth of the threads, they have to cover all the section, right, which is 20 even the side. All right, so now you can apply a thread and then want to apply it here, right? and it's M16 by 2, okay, which is correct. And then even on this edge we need another one, sorry, thread M16 by 2, there you have it. And then now we need another one this side, which is M16 by 2. Okay, so now the only thing that you are left with is assigning material for your shaft. Okay, so for the shaft we're told that it's it's mild steel, there we have it. So you apply material here, you assign material, and then you want steel, and then you can just click S to quickly go there. Okay, and then want mild steel, so there we have it. And then now, after doing all of this, you'll just click here. Remember, before starting the drawing, we saved our shaft, right? So now you just have to click here to save. And then it is saved automatically where we all created our folder, right? So when we come here now on our folder, there we have our shaft there. Okay, all right. Okay, we're done with the shaft, guys. So let's move to this component here, right? And now it's already past 20 minutes past, so I think everyone now has joined the session. Okay, so I think there are about 2 to 3 dimensions that we're missing here. One of them being this one here, this radius here, it's R11. It's the one that was missing. And then also this distance here. Sorry. This distance here is also another one that was missing. So this distance, it's for this distance here. Okay, I'm not so sure if you can see, guys. Okay, so it's 4. All right. And then also this one, it's also missing this one, which I believe that it's I think it's 28. I'm not sure, but we'll come back to it. All right. Okay, so guys, now the main question is, how do you go on about creating this bracket, right? Okay, actually it's not too complicated, guys. But yeah, you can see that it has many dimensions, so it may look scary, but it's actually not. So the only portion that you have to start with is this section. Sorry, it's this section, guys. This section. And how do you go on about drawing this section? You only just have to draw the upper part only. So we have our center line here, and then now just have to draw this profile. This profile, guys. Let me erase this one. So I was saying that we just need this profile, which goes like that, and like this, and like that. Yeah, so that's what we need, guys. That's what we need. Okay, so let's get started. Again, let's create a new part file, which is IPT file, like that. Okay, otherwise that part alone, guys, well, it can take you maybe about 30 minutes in your assessment, and you will be having 2 hours, so 30 minutes, you still have 1 hour 30 minutes remaining. So guys, there's no excuse for not completing your drawings. Okay, so like I said before, that before even drawing, you have to save first. So now what is it that we want to save? It's a bracket, right? And you can see where is it saved. It's saved in our folder there, and we already have the shaft. And then save. Okay, and then now we can start our 2D sketch, right? And then I'm going to use the XY plane. So again, you know, for starters, we need our center line. There we have it. And then now, let's see. And then now what is next is, sorry, I can see that many people are still joining, and I just hope everyone will not miss out on this component. So remember guys, I said that this is the profile that we want to draw, right? This is the profile, right? Okay. So we know that, okay, we'll be having our center line here. So we know that this hole here is diameter 24, which is given. And then again, we know that it's diameter 64, this one. And then we know that the next one is diameter 105, right? Okay. All right, so you just started to sketch that looks like this. Remember, it should resemble what that profile I was showing you guys. It goes like this, like that, and like that, like this, like this, like this, and like that. Okay, so let's come back here. We have diameter 24, we have diameter 64, and diameter 105. So we know that this one is diameter 24. There you have it. And the next one is diameter 64. And then, guys, please unmute yourself unless you have a question. Then yeah, you can ask. And then the next one is diameter 102. Is it 102 or 105? It's 105. Then the next one is 152. So let's edit this one to be 105. So we actually don't need this one and that one, right? We just have to extend this one, and then now let's trim this portion here. So the next one is what? It's 152, right? Okay, so you have this, right? Then now let's come back again to our sketch. Now let's delete this profile because we already have it. We no longer need it again. So now we know that from here to here, it's what? It's 22, right? There it is, 22 there. Sorry guys, it seems like someone is okay, but I don't see a hand. All right, okay, let's continue guys. Anyways, if you guys have any question, you can just unmute yourself and then just ask. Okay. All right. So we know that from here to here, it's 22. Have it. And then from here to here, it's 6, right? Okay, so here's what I'm talking about, guys. From this circle of diameter 150 to this one of diameter 64. What happened? I'm saying that for this surface of diameter 152 to this end, diameter 64. We're given that it's 22, the distance. And then again, from this diameter 52 to this diameter 105, this small portion here, we're told that it's what? It's 6. Okay. And then we also know that the thickness of this diameter 152 is 12, right? Okay. So let's come back to our sketch. So we're saying that now this one, it's 12. Have it. Okay. Just delete this one because we're missing something. What is it that we're missing? We're missing this portion, this one, right? This is the portion I want to add now. Okay. So what is this diameter here? Okay, as you can see, it's not given here in the what? In the what? In the front view, right? But then where will we find it? We'll find it here in the front view, in the front view, right? So there you have it. It's this one. So meaning that it's what? Meaning that it's this radius 28 here, okay? Meaning that the diameter will be what? 28 by 2, okay? So this diameter here should go all the way to somewhere here, right? Not here. Is this diameter, guys? It's R28, right? So now, I mean that when we come here, let's quickly do this. All right, so this is our profile. So I'm saying that this diameter, it's radius 28, so it's going to be 28 by 2. So there we have it, it's diameter 56, and then this one is given that it's diameter what? It's diameter 38. So now, what is the distance from here to here? Okay, let's go back. Well, that one we don't know, but then what do we know is that the distance from here, the distance from here to there, it's 42. There it's given. So you come here, we're saying that the distance from here to here, it's 42. Okay. So let's come back again now. Here we need okay, you see this line, it's at an angle, and that was not specified, the dimension of that angle here. But then if you were to read your drawing, you would see that this portion here, it's where your spacer goes, right? It should be like this. Your spacer should be there, like that. Okay, so let's see. Where is our spacer? Our spacer is here. And then we know that its total length, it's what? It's 32. There we have it. And also we know that that angle is 30 degrees. Okay. So I'm saying that we now know that the angle is 30 degrees and we know that the length is 32. Okay. So now coming back here, we know that from this end to here, to this end, it's what? It's 32. This one, because we know that that's where our spacer has 2 feet. And we also know now that the angle is 30 degrees. Let's go back. We're saying that from this point to there, it's 32. There we have it. So now you can see that our drawing shifted to the left, right? So we need to bring this point to be in line with the origin here. So how do you do that? We're just gonna use this coincident, want this line to be in the same straight line as this one. Okay, so there you have it. But then now this one shifted, you just have to come to this point and drag like that. Okay. So now we're saying that this angle is supposed to be 30 degrees. There we have it. Is it like this? Let's see. Let's come back here. Okay, we're saying that the spacer has to fit there, and then it's 30 degrees that angle, so meaning that this one it's not 30 but it's 60. It's 60 degrees, this one, right? Because if this one is 60, meaning that this one, now if we were to draw a line here, this one is going to be 30 degrees. So there you have it. Okay, delete that one. Okay, so now we're done with the profile, guys. We're done with the profile. So we drew this profile, this one. Okay, but then it seems like we're not, because now we're missing this portion here, this hidden detail line here of an arc, this hidden detail line, and we're told that it's what we're told that it's radius 10, right? It's radius 10. So what you have to do is to come here now, right? And where is it? So between diameter 64 and diameter 105, right? Okay. So we need an arc here, right? Of radius 10, not diameter 10, guys. Sorry about that. It's a radius 10. We have it, and we know that this point should be on this line. Okay, already it's there. And then now we just have to trim this portion. Okay, so now there we have our profile, guys. It's complete like that. And then now from there you just finish your sketch and then revolve. Okay, so there we have it. Okay, now let's quickly just and then let's do it like this. Yeah, this is the profile, guys. So you can see that it is the same as this one, right? It's just that now what are we missing? We know that there's this radius here, and also what we're also still going to add these holes. Okay, but then the profile, we're done with it, and from there it should be straightforward. What is next? The next part now is this shape here. That's the next part. Okay, so this shape, it starts from here and then goes all the way to here, right? Okay, what do we know about that shape? We know that okay, we already know what is it that we know, guys? We already know this one, right? It's radius 28, and then you know that from here to there it's 70. What else do we know? Okay, is this missing dimension that I was telling you guys about, that this one, it's radius 11. Oh, sorry, it's radius 11. Okay. And also the small holes, it seems like I didn't put the dimensions, but then they are the same as these ones here. No, sorry. No, they're not, guys. Because if you can see, these ones are threaded, right? So meaning that it's this hole here. And we're told that it's an M10 with a depth of 19. And how many of them? There are 2. So meaning that it's 1, 2. All right, let's get started now, guys. So now we need to start a 2D sketch here on this surface, right? And then we can just project this geometry because we know that it's already diameter 54. This one, it's 56, radius 28, right? And then now we need two radius R11s here, which will be R11, which is 22, right? And also 22. Okay. And then you know that these ones have to be in the same straight line as the origin, right? And then now we know that from here to there, 70, from this circle to that one, center to center, 80. And then meaning that from here to the center, it's what now? It's 35, which is 70 divided by 2. So there we have it. And then now we need lines that will be tangent like that, and like that, and sorry, and like that, and also like that. So we know that this line has to be tangential to this one and also to this one here, and also there, like that, and like that, like that, like that, and like that. Okay. So now we can trim the unwanted parts. So we don't need this one, we don't need this one, we don't need this one, and this one, that one, and also this one here, that one, and that one, and also this one. We don't need this one. Also don't need this one and that one. Okay. So now what else should I do? I should just put points here, here, and there. So what will these points do? These points, they will enable me to draw this hole here. Remember, you have to use a whole feature for this hole here. Okay. Okay, but you guys can see what I'm talking about. It's this hole here. All right. Okay, so now we're done here. We just have to finish our sketch, and then we extrude. What is it that we want to extrude? This is what we want to extrude. And then we just click to the surface, right? Okay, so there we have it, looking like that. And then now we need to, okay, this is what we have now. So now what do we need? We need to drill those holes, guys. And now what we have to do is just share the sketch. Make the sketch to be visible. Why making it visible? Because we want these points here so that we can apply our whole feature. Then now you go 3D model hole. Okay. And then now what kind of a hole do we want? We want this type of a hole. So this is the want this type of a hole, and then just goes like that. This is the type of a hole that we want, guys, because you can see that it's not just a standard hole that goes through. It has this sharp edge here, right? This one here. Okay. So since it has that, meaning that we can't just use this one, right? We want the end to be sharp. And then what is the diameter? We're told that it's an M10. So it's diameter 10. And then what is the depth? It's 19, right? It's 19. Okay, don't be confused, guys. Here is the depth that I'm talking about, this one. This symbol here, sorry. This symbol here, it means, it represents a depth, yeah. So it actually, when you are reading this, it means there are two M10 holes that are 19 millimeters deep, okay? So let's come back here. All right, so we'll be having our holes looking like that, okay? Then click on OK. So now we no longer need the sketch again, we don't need it. Okay, so what else do we need? We need those holes, those 5 holes that are here, right? Which is these holes, these ones, and we are told that they are 5, the quantity. And what type of holes are they? They are countersunk holes, right? Countersunk or countersink, whatever it is. So again, you have to know how to read your symbols, right? So this symbol here, it simply means that it's countersunk. Okay, even without having to know that symbol, but you can see here that we have 2 diameters. You have diameter 20, you have diameter 12. So meaning that the outer diameter, it's diameter 20, and the inner diameter, it's diameter 12. Okay, all right. And then we're told that the angle is 15 degrees. And what angle are they talking about? This is the angle, guys. This angle here. It's going to be 150. Sorry guys, I can't write with this thing. But yeah, it's 150, that angle. Okay, and we're told that these holes are 12 millimeters deep. We're told again. So what does that mean? It means that it's this 12 here. The depth is this 12 here. Okay. Sorry. Okay, now let's go back. What we need again, we need to start a 2D sketch.
Will, I think you're muted.
Okay. I was saying that now, guys, we need to create those countersunk holes. I believe that you heard me on that one. And then now I was saying that what is the distance now from the center to that hole? We need this distance, right? Okay, so how do we figure out that distance? It's here, it's given that the pitch circle diameter is 124, right? Meaning that if you were to draw if you were to draw a circle here, so it won't work. But if you were to draw a circle that bisects these circles at the center, its diameter will be 124, meaning that the center is 124 divided by 2, right? Now let's come back here. So what I'm saying is that if you were to draw a circle like this, it would be 124, the diameter. And then you know that this point, it has to be here, right? So that's what that PCD mean. But then now we don't need this one, unfortunately, so we just have to say from here to there, it's 124 divided by 2, which is 62, right? And then we are done. Okay. Go to your hole feature again. But then now, what type of a hole do you want? You don't want this type of a hole, you want a countersunk hole, right? So, which is this one? Countersink. There you have it. And then you are told that the bigger diameter is 20 and the smaller diameter it's 12. And then what is the depth? It's 12. We did talk about that. Okay, but then now what is the angle? Again, it's given that it's 150 degrees, like that. Okay, so there you have it. Okay, so now what is it that you have to fix? You see this outline here, we don't want this, so meaning that we just have to make it like that. So now there it is, the total depth it's 12, and then the bigger diameter it's 20, the smaller diameter it's 12, and the total depth it's 12, meaning that from here to there it's 12. So there you have your hole looking like that, and then click on OK. So now we are told that we have 5 of these. So now from there you just have to go to circular patterning. What is it that you want to pattern? Is this hole here, and your axis, I want it to go around these axes. And how many of these holes do you want? We are told that they are 5, and then you just click here, meaning that if maybe we're told that they are 10, you're just gonna place 10 here, but then now we're told that they are 5. Then click on OK, and then there you have your holes. Okay, so meaning that now here we are done with everything that is, what's happening now? We're done with everything that starts from here to here. We're done with everything on the side, right? Now what we're left with now is this portion now. This portion, which is this portion here. Okay. So now what do we need to do now? Sorry. Guys, if I'm moving too fast, please just unmute yourself and then say I'm moving fast and you like me to repeat some steps, if there are portions that you like me to repeat. Okay. All right, now let's progress. Okay, now guys, we're told that the distance from here to here, from there to here, it's 114. Here it's given. It's 104, right? Okay, it's 104. So meaning that for us to be able to draw this profile that I highlighted this side, we have to start a sketch that is 104 millimeters away from this surface. Okay, let's come back here. So now we need a plane that is 104 millimeters from this surface, right? So you go to plane and then offset from plane. Which plane do you want to offset from? You want to offset from this plane, going that side by 104 millimeters, right? So it's going to be minus 104 millimeters. And there you have it, like that. So now we can start our sketch here. Okay. So we need to draw this profile, guys, the way I highlighted it here for you. so we have to draw it. So how do we go on about doing that? We know that this one here, we know that this diameter, it's diameter 50, which is this one. And we also know that which one? I think this one, this hole here, it's diameter 30, right? And then now what about this one? This one we're told that it's radius 92. There you have it. It's radius 92, but then it's radius 92 from where? It's radius 92 from 48 millimeters from the origin, okay, like that. So we know that from center to there it's 48, and then this one, this arc here, it's what? It's radius 42, okay. So now let's come here. We have to draw a circle which goes like this, and we know that it's radius 92, so that the diameter is 92 by 2, okay. And then we know that from the center to there it's 48. There we have it. And then you should make sure that this point is in the same straight line as the origin, so that it doesn't shift when you are working, right? All right, so there we have it. And now what is next? Is that there's this hidden detail line here, right? Okay, and then what is the thickness? The thickness is 10, right? Thickness is 10, and here it's given here that the thickness is 10, okay. All right, but then we'll come back to that. What we will need to do now is to draw this sorry, what we draw now, we need to draw this arc here and also that one, which are radius 25, right? Okay, so now let's come back here. So since I know that I have two of those, I can just only draw on one side, right? And then I use what? A mirror, okay. So we're saying that it's R25, meaning that the diameter has to be 50, okay. And then now I need a line here which goes like this, okay. And then I make it a construction line. And then again you have to constrain it to the origin, okay. So we have it, this one, it's diameter 25, and we know that it's radius 25, guys, sorry about that, it's radius 25. So we can see that its center is in the same straight line as this one of this hole, meaning that it's 35 from here, because it's 70 divided by 2, so meaning that this distance here is 35, okay. So what I'm saying is from here to here it's 35, okay. So we did that. What do we need now? We need this to be tangential to this, okay. And there you have it. And then now what else do we need? We need this line here. We need this line, and we're told that it is what? It is 9 millimeters from the center. Here it's given here. So you come here, we need a horizontal line, just like this. And then we're told that this horizontal line is 9 millimeters from the center. So there we have it. Okay, so now what else do we need? We need what? um okay, you can see that there's this arc here, and then what we can do is that we can just draw this whole profile, right? Sorry, this whole profile, this one, right? Okay, so we know that it's diameter 50, right, and diameter 30. Okay, so we need to start a circle of diameter 50 and another one of diameter 30, right? So now I think we're almost done here. All right, so now let's trim any unwanted parts just so that our sketch looks better. All right. Okay, so this one, it wants to go all the way. All right, what I can do is that I need to trim this one and that one and this one and that one and that one and that one. Okay, and also this small portion here. Even this line, I don't need it going all the way, right? But then now I need a line now that will go up here, right? And then this line, it has to be tangential to this one. And then again, I trim here, here, and there. All right. So that is what I have. Okay. So what I just did, I added a vertical line here, like this. A vertical line like this. So this is the profile I am having now, which will look like this. Never mind the arc, we'll come back to it later, that one. Okay, we're done with that. Now what do we have to do is we have to mirror this one to this side, right? So we just go to the mirror feature, want to mirror this one and this one and this one. And then which line we want to mirror about is this construction line we draw here. And then you click on that line, apply, done. So there we have that profile looking like that. And then now we have to trim now this one. We don't want it. Okay. So now we have this profile, guys. We now have this profile looking like this. All right, so now we're going to extrude now, okay? And then what we know that this thickness, it's 10, right? So here it's 10. And then we know that we are drawing our sketch here because remember we offsetted the plane by 104 millimeters from here to there. So meaning that we have to extrude going to that direction. Okay, let's come here now. We finish. Wait guys, are we done? We're not, guys. Just to avoid creating many extrusions, guys, remember we also have this one, right, which goes like this. And then we know that the thickness is 10. So now how do you get that one? You get that one by offsetting, right? What are you offsetting? Offset this one by 10 millimeters, like that. But then now we don't need this, and we also don't need that, even this and that. So now what you have to do is to just extend this one all the way. Sorry, let's undo. We need to extend this one and also this one. So now we have it, and then from here I think we're done. We can just now finish our sketch and let us extrude. Okay, so remember I said that we are here, right? We are here, meaning that we have to extrude by 10 coming this side. So this is what we're extruding by 10, right? Going to that side. There we have it. Okay, and then now plus we need to extrude now this one, which goes all the way to here. Okay, like this, right? And which portion is this? Is this portion, guys, which goes all the way from here to there? This one. Okay, and then now we're missing what? We're missing sorry. So now what else we need to know is how now are we going to extrude this profile that is left here, this one. Okay, so we're told that the overall distance is 39 and we are here. That's where we are at, meaning that we have to extrude going to that side and also extrude coming to this side. But then I did mention it to you guys that this distance here, it's 4 millimeters. This one here, it's 4, right? Assuming that since we're here, we have to extrude by 4 coming to this side, and then now by 39 minus 4 going to that side. Okay, so now let's add another extrusion, which is this extrusion. So we need 2 distances, right? So I said that we're going this side by 4, right? And then going to that side by 39 minus 4, like that. Then we click on OK. All right. And now we no longer need this one, right? We no longer need this one. Okay, so now this is what we have. All right. So, okay, guys, now I'll just try to be a bit quick. I'll try. Okay, so now there's this portion here, right? This portion. And then what do we know about this portion? Which means that it's from here to somewhere here, right? So meaning that we need to start a 2D sketch here, right? We need to start a 2D sketch here. And then what you can just do is to slice slice the graphics. Okay, but okay. So which profile now do we want? We want this profile, guys. This profile that goes like this, and like that. This is the one that we want. Okay. All right. So let's figure out some distances here, guys. We know that from here to here, it's what? It's 32. No, it can't be 32. It has to be 30, right? Because it's 42 minus 12, right? Which is 32. Yes. Guys, is it 32? Sounds like my maths is not mathsing now. It's 30, eh? All right, 42 minus 12. Forgive me, guys. It's been a long day. Okay, so it's 30. All right. So we know that from here to here it's 30. But then now, what about from here now to here? Okay. Since we know that we have this radius of 3 here, meaning that this smaller portion here, it's what? it's 3, the small portion here. Meaning that now that profile goes by meaning that now from here to here, it's what? It's 27, because it's 30 minus this 3. Okay. So remember, we're creating our sketch here. So what we have to do is to project this geometry, and that's one, and that one, right? And also this one, and this one, that one, and that one, and that. We don't need that one, sorry. Okay, just for you guys can get a picture of what I'm doing. Hey guys, sorry guys. But you can see this is the profile, guys, that I'm creating, this one here. So here you can see it, there we have it already. So now we're only missing a line that goes from here, all the way to there, right? So that our sketch can be closed, right? Okay, so now you can see that we have space here, meaning that we didn't project all of we didn't project everything, so we need to project this one and also that one. Okay, now let's see. Yeah, so now our sketch is closed, right? So we just have to trim this line here. We don't want it. So this is the portion that we're going to extrude, right? Now we can click on extrude. We're extruding this. And then by how much we did the calculation, guys, we said it's 30 minus 3, which is 27. And then click on OK. So there you have it, like that. Okay. You have it looking like that. All right. Now what is missing on our bracket is sorry. What is missing now? I think we're just missing this arc, and also these arcs here, and also here and here. All right, now coming here, guys, we're told that okay, this radius is this one, but sorry guys, I also missed another dimension here. It's R6, this curve here. This is, yeah, it's R6. And sorry if you tried figuring out that. Okay, so now we have to fillet. As I was saying, that that dimension, it's R6, so that we have to fillet by 6. Okay, fillet by 6, and what are we filleting is this one, like that. Okay, but then now what will be the fillet here on the outside? Okay, how do you find that? You know that the thickness, it's 10, right? So meaning that the outside fillet will be 10 plus 6. It's this radius plus the thickness, right? So meaning that now we have 16, right? 16 for this one, like that. So it's 16. So why did we say 10 plus 6 for this outside fillet? Because we want to keep this thickness 10, right? So for us to keep that this thickness to be 10 is that the outside radius, it's the inner radius plus the thickness. So please keep that in mind, guys. It might be applicable somewhere else. Okay. So now we're done with that. What other fillet do we need? We need this one here. It's also 6, like that. Sorry, what's happening? Okay, fillet. There's this one, it's also 6, not 16, 6, like that. And also there is this one 6 also, and then also this one. Sorry guys, I selected the wrong edge. Okay, let's come back here and figure out these fillets I'm talking about. So guys, we need this fillet, we need this fillet, we need this fillet, we need that fillet. So this one, it's R3, it's R6, not given. Okay, so let's fillet. Okay, for this one we can use 16. Guys, yeah, fillet here, guys, like that, and also here like this. And then now we also need a fillet of 3, which is this one here, like that. And we need a fillet of 6 again, which is this one. And also this one and this one. Then okay, so now you have your bracket looking like that, like this, from the top, and like that. Yeah, there's your bracket. But then now what are we missing? We're missing an oil hole here, which is diameter 6, this oil hole. Okay, and we know that this oil hole is 16 millimeters from this end, right? Okay, just to double check something, guys, we should double check this dimension, this one. So how do we do that? We come here and then we go to tools and then measure. We have to confirm that from here to here it's 139. Okay, it's correct, guys. Okay, so guys, and you guys have been asking a lot about an oil hole, so I'll just show you guys how to draw an oil hole. Okay, for you to draw an oil hole, you need a plane that is tangent to the surface. And this surface is circular, so having a plane that is tangent here can be difficult. But then how do you do that? Remember, we have this sketch here, this one. You just have to come to the sketch, edit the sketch. And what do you want to add on the sketch? You just want to add a point here, right? Here. So if you were to draw a line that is horizontal, that line will be tangential to this circle, right? So, but now just use the point, okay, and then finish sketch. What you have to do now, you have to make that sketch to be visible, right? Like that. Okay. So after making it visible, you go to your 3D model and then want a plane. Remember, we said want a plane that is tangential to the surface. So you want a plane that is tangent to a surface through a point. As you can see, this is for cylindrical, circular or cylindrical parts. So want a tangent that is surface, a plane that is tangent to a surface through a point. And where is that point? Is this point, guys, this point here in red, the one we just added, and then you just double click there. So you see now there you have your plane, right? Like that. So now we no longer need the sketch, but then we have our plane. There is our plane. So we need to start a sketch there. So we need to start a 2D sketch in this plane. And again, the only thing that we need is to just place a point, right? And then our point should be 16 millimeters from this end, like that. And then finish sketch. Okay, and then this plane, you can make it to be invisible because you don't need it anymore. And then what is the diameter of our oil hole? It's diameter 6. Okay, and then now we want a hole, right? But then what type of hole? Just want a simple hole, right? Which is diameter 6. right? Like that. But then now, what is the depth of that hole? Coming back here, you can see that this hole doesn't go all the way through. It only ends here. And then how do you do that? You just come here. You say 2. So when our hole to be drilled from here to which surface? To this surface, the inner surface. Like that, guys. Like that. And then you click on OK. And then there you have your oil hole. Like that. Okay, so let's see. Let's view half section and then XY plane. This is our bracket. This is our bracket, and it should look like this. So we're done with our bracket, guys. We're done. And it seems like it took us more than enough, about 50 minutes. But at least that's still enough, guys, in your test, because we'll be having 2 hours. Okay, so now
there's another hole, the 12, diameter 12 in that bracket.
Oh yes, thank you. There's this hole here. Okay, diameter 12. Okay, but then again, it seems like I missed the dimension from here to here. Okay, and then sorry again about that, guys. I also don't remember it. Maybe, I don't know, from here to there. I don't know, what is it? Maybe it's 54. I don't know. 54, 64, but we shall see. Okay, and then how do you go on about drawing that hole again? You use the very same method we used for drawing this hole. And then how is that again? You need a point, right? Where do you need that point? Remember, we need a plane that is tangent to this surface now. Again, you need to come back to the sketch. You edit the sketch. You want a point here. Here, you want a point here, right? And then finish your sketch, and then let's make it visible. Make the sketch visible, right? And then again, we need a plane. It's just a repetition of what I did on the other hole. We need a plane that is parallel to a surface through a point. And where is our point? There is our point. Sorry. Okay, there we have it. And then yeah, there we have our plane there. And then now we don't need the sketch anymore. And then now let's start a 2D sketch on this plane, right? And then again, we just need a point. Let's put it here. And then the dimension, I'm not so sure about it, guys. I'll confirm, but it should be 54. Okay, finish sketch. And now again, we no longer need this plane. Need it, so just make it to be invisible. And then now hole, right? Okay, so there is your hole, and this one, it's diameter 12. It's diameter 12, and again, to which surface? To this surface. And then click on OK. Then there you have it. There you have it. There you have it. Like that. So after doing that, now I believe that our bracket is complete, guys. This is what it's supposed to look like. This is what it's supposed to look like. Okay. Any questions, guys, on this bracket? Because I'm sure that it was the only challenging part. I'm sure of that. Any questions, guys? Okay, we need material. It's cast iron, so iron cast. There we have it. And then you can save. And then you click click on OK there. And you see now it doesn't ask me where do I want to save my bracket because I saved it before starting drawing. Remember? Okay. So, okay guys, let me quickly confirm something here. Our session is ending at 7:45, meaning that 20 minutes from now, ne? Okay. So yeah, 20 minutes from now. And how many parts do we still need to draw? We drew the bracket, we drew the shaft. We don't have a pool, we don't have a space, we don't have a gland, we don't have a wheel, and we don't have a push, we don't have a stud. Wow. Okay. What we can simply do is to go to the pool because I think it's another challenging part for you guys. Okay, let's go to the pool then. Here's our pool. And again, for a pulley, just the revolve feature, guys. Remember, you only just have to draw the upper section and then you revolve. Okay. So let's create a new part file. And then, like I said, before drawing anything, you have to save your file, right? And then this is our folder where we're saving. We already have a bracket and a shaft. Now we need a V pulley. And then we started 2D. Sorry, it's still loading, guys. Okay, we started 2D sketch in our XY plane, and then we need a center line. There we have it, center line. And then again, we just have to okay, so guys, one thing that you can also notice here is that if you were to cut this pool here in the middle, this left section is the same as the right section. So you don't need to draw all of that. You just have to draw one side and then you mirror, okay? But you can draw the whole thing, it's fine. But for this one, let's just go for a half section, like that. Our line should be from the origin. Then we need make it a construction line, this one. Okay, so we can now draw our profile for our pool, which looks like this and like this. Like that. So that's all you need for this pool. Then you just have to put on dimensions now. So the outer diameter is 152, 126, and 30. So this one is diameter 30, it's diameter 52. Guys, what am I doing? It's diameter 30 and it's diameter 126 and diameter 152. So we actually don't have this. Guys, what's happening? We don't have this. No, we do have it. We do have it. Okay, guys. Diameter 30, but then there's this one right here in the middle. No, guys, I'm tired. No. This one here in the middle, which is diameter 19, right? Is it diameter 19? Yeah, it has to be. It's just that I missed it. Yeah, it's diameter 19, guys. But you can even figure it out from here. You see, this section, you know that it has to fit here. because this is 29 and this is 29. So this section is the one that will be here. Okay, and its diameter 19. So it's diameter 19 and then diameter 30. And then diameter what? Diameter 126 and diameter 152. Diameter 120, diameter 126 and then diameter 152. Okay, we just have to extend this center, this construction line of ours. You can even take it up there. And then we're told that this angle, it's what? It's 40 degrees. But then since now we're only drawing half, meaning that it has to be 20, right? Because now when it's complete, it will be 40 degrees, right? And then we know that from here to here, it's 27. Fine, guys. So 29 divided by 2, remember we're drawing half of this. Okay, so now we just have to do this. And then we know that from here to here, it's 16. Okay, we have this one, and then now which one are we missing again? It's from here. Okay, let's come here quickly. I'm saying that we have this one as diameter as 29 the length, and then now we need this one here, which is 27, right? So meaning that now from here to there, guys, yeah, I think that from here to here it's 27. So what is 27 divided by 2? And there we have it, guys. So with that, I think we're done with our, oh, we're not done here. This thickness is 6, so meaning that the half is 3. What's happening? What's happening? What's happening? Oh, okay, let's see. There we have it, guys, and then we just now have to mirror this, all of this, and then our mirror line is this one, apply, done. Okay, and then now just revolve. And then our revolve axis, here are they. And then you're done, guys. There is your pulley, just like that. Okay, so what is the material? It's cast iron also. So you just come here, cast iron, and then save. All right, guys, I just want to make sure that I do an assembly before our session ends. But I don't know if, can I extend here? I don't know. Let's see. By just 15 more minutes. Because as 10 minutes, in 10 minutes, yeah. So let me just see. I'm not so sure if it will update on the main meeting. I don't know, guys. Okay, let me save. I just hope that it will update. I just hope. All right, it did, guys, it did. Okay, so now let's continue. Oh, the next part, it's what? It's the okay for the bush, guys. I don't think I'll draw this one. I don't think I will. I won't actually. But then the bush you are given, that is diameter 30 and diameter 24. And now again for this hole here, you use the same method that we used here. Right? You'll know that after extrude, because you'll draw these two circles, right, and then extrude by 39, and then now go back to this sketch and then just add a point and then create a plane that is tangent to that point. Like, it's just for you guys to practice it and also just to apply what I did so that you also know how to do it. Okay, so I want to draw a bush, and even the gland, I don't think I will draw it. I don't think we have enough time, but I'll see. But even the gland is not it's not complex. Okay, let's come to the gear wheel, guys. What do we know to the gear wheel is that we know that the inner radius here is radius 46. We know that this one is diameter 38, and we know that this one is diameter 19. Where do we get that is diameter 19? It's written here, 4x4 QA in diameter 19 bore, right? But again, even if this information was not provided, what is your overall length of your gear? It's 32. And then come back to your shaft. Where do you have a 32? We have a 32 here, meaning that this portion is the one that goes in here. So yes, diameter 19. Okay, let's get started. Create a new part file again. And before drawing, you save that file. And what is it? It's a gear wheel. Okay. And then start a 2D sketch. Here, XY plane, and then we just need three diameters. So we know that's diameter 19, and then diameter 30. Is it 30 or 38? I don't know. I'll double check. And then 46, R46, which is 46 by 2. Okay, let's come back. Oh yes, it's 38. And also you can even draw this keyway here. So how do you draw that one? You just have to draw a line like this. And then we're told that it's a 4x4 QA, right? So you just have to extend this one. Okay, so if it's a 4x4, meaning that this is 4. And then from here to here, it has to be 2. And then also again from here to there, it's 4. Okay, and then you can trim this one. You don't want it, and then finish sketch. Now let us extrude. Let's start with this and this. We're extruding by what? We're extruding by 30 by 19. The gear, which is 19. And then we just have to add an extrusion. Now we need this one, and then we're extruding by 32, and then it's solid. No, the other way around, like that. Click on OK. So there is your gear like that. But then now we need what? The of our gear. So we just have to start a 2D sketch here. Okay, so not like the information was not provided on the gears, but we just know that they are 50. So any design would have been appropriate. So let's just say you decided to go for a design that goes like this, like that. And then let's say from here to there, maybe you can make it 50. Okay? And then from here to here, you can make it what? You can make it 2, right? And then we need to move this point like this. So if this is 2, meaning that from here to there it has to be 4. That I just have to fix this one. Okay. So now we also need to work on this angle. Okay, let me first delete this one. You can use any angle here. Okay, let's say maybe we use the 15 degrees or even 20, doesn't matter. Okay, so that is 20, right? Okay, but then now you can see that this is not symmetric, right? So you can just draw a line here. Like this. And then if this is 20, meaning that this angle now it has to be 10. Yeah, so now our gear is proper. Leave this one. You can even chamfer or fillet your gear teeth, it doesn't matter. So let's see, fillet maybe by 1.5. So yeah, there we have our gear looking like that. And then now just have to finish sketch and then extrude. What are we extruding? We're extruding this to here, like that. Since now we have that, and then they say 150 of them, you just have to go to circular patterning. What is it that you want to pattern? Is this extrusion and your axis, it's these ones. And how many do you want? You want 50. Okay, and then there you have your gear looking like that. Okay, so what is the material for this gear wheel? It's let's see, it's mild steel, right? So and then now you have to assign material, steel, like that. And then now you just click on save again. So you don't need to select a folder again because you already saved before. Okay, so guys, since I was telling you that looking at the time and looking at what we have and what we still have to do, because I really need to show you guys how to create your part list, your balloons, and sectioning. So a stud and a bush and a space and a gland, we can't draw them, guys, because of time, but they are straightforward, all of them, because it's simply these 3. It's 1, 2, 3. Oh, and also this one, 4, and then you're good to go. Okay, however, since I already have this drawing, so now for me to illustrate as an assembly for you guys, I'll just use the parts that I already have. But okay, now let's go to assembly. Let's create a part. But then now what part do we want? We want the standard millimeter.iam. So we want an assembly file. Okay. And again, before doing anything else, we need to save, right? Save And what is it that we're saving? It's a V-belt assembly. Okay. Okay, so now let's place our components. Okay, so let's place, and then what is our main component? It has to be a bracket, of course. It's not the one we want. So where did we save our work? This is where our work is, so here. And then a bracket. Okay. And then we place it like that. Then okay. And remember, our bracket is our main component, so that we have to ground it, right? Ground it, there we have it. Okay, so what is the next part that we're going to place? Okay, I would go for a pulley, right? I'll go for a pulley, so let me place the pulley. There is the pulley. But, let's change the color of this pulley, guys. Now we're not changing the material, but we're just changing the color now, the appearance. The material remains the same, it's still cast iron. Okay, we just changed the color. Okay, what else do I need? Okay, if I were to check, this diameter is not the same as that diameter. This is diameter 19 and this is diameter 38. So we can't say a 19 goes to a 38, no. But then now what do we need? We can place a shaft, right? There is our shaft. Then click on OK. All right, so coming back to here, what is this distance? What is this dimension? It's 29, right? And then where is our bracket? This is our bracket, okay? So this is 39, okay? Meaning that here in our shaft, guys, what am I saying? Okay, I'm saying that we're coming to our shaft, right? We have this distance of 29, right? Okay. And where else do we have 29? Let's come to our pulley. Here, this distance from here to here is 29. Meaning that this portion, okay, meaning that this portion here, it has to fit here. Okay, so now let's go back to our assembly. So which one is the one of 29? You can just measure from here to here. Okay, there we have it, it's 29. And then we insert assembly constraint. We know that, and then insert for circular parts, we insert. So this is a 29 and it's diameter what? Diameter 19, and here's another diameter 19. And then like that, we have it, cancel. All right. Okay. So now, what I will place now, guys, it's the bush, right? I didn't draw it for you, but I have it, the bush that comes in here. Because the bush, it's diameter 30, and even this, it's diameter 30. So the bush goes in there, and even the length of our bush is 39, so I mean that it fits here, right? Okay, let me place. Okay, there is my bush. And then we know that from this end to this hole it's 16. Even here from this end to this hole it's 16. Meaning that we need to insert this diameter 38 to this diameter 38. And then you just have to oppose the direction, and then there you have it. So I believe we have to look at the top view, those holes have to correspond, right? Okay, let's quickly do this, guys. View, and then like this.
I think you've been muted.
Sorry, guys. I don't know how did that happen. But okay, let me just quickly go through what I did. So push, and then I delete this. Okay, so there's my push, guys. What I was saying is that this diameter is diameter 38. Even this one is diameter 38. So meaning that this push has to go in here. And also this hole is 16 millimeters from this end. Even this one is 16 millimeters from this end. So meaning that this hole has to correspond with this one. So now let's insert our push, and then constraint insert. We want to insert this 38 to another 38 like that. But then now just have to reverse direction and click on apply. Cancel. So that's what you have. Okay. So we know that the inner diameter of this push, it's what? It's 27, right? It's 24. Even now this bigger diameter of the shaft, it's 24. Meaning that 24 goes to another 24. So now constraint insert. What are we inserting? We are inserting a 24 to another 24. Inserting a 24 to 24.
It's so William.
Sorry?
I just wanted to ask, like, how did you slice the graphics in this mechanical assembly?
All right, let me quickly illustrate that. Maybe I did it whilst I was on mute. Okay. All right, so guys, as you can see that in this drawing, many of our components need to be assembled inside this bracket, right? And now, with that being said, for example, if I were to insert a space, I know that a space has to go inside here, but I can't select what is inside there because of this outer profile, right? So now, to make things easy for me to be able to select what is inside this bracket, I have to go to view, right? And then what type of a view that I want? I want a sectional view. So it's either I want a half section or a quarter section. But for this one, I think a quarter section will work better than half section. So I want a quarter section. And now to create a quarter section, you need two planes, right? Because it goes in the middle vertically and also in the middle horizontal, right? So which planes do I need? I need this plane that goes in the middle vertical, this one, on your origin, right? On your origin, this one. I need this one, you click on it, and then you just click on this arrow. And then now you need a second plane now, the one that goes horizontally. So here it is, it's your XZ, and then you just select on it, and then click OK. There you have your half section view. Okay, So I was saying that a 24 has to go to another 24. Okay, constraint, insert. Okay, let me do this. Okay, so here, remember we're saying that we want this 24 to go to another 24 here, but then because of this fillet, we can't select, because check what happens if we select this and that. Click on apply. You see now this one is outside, of which you don't want that. So click on cancel. You just have to now to insert this one to this one, then opposite direction, and then now you have it looking like that, and then click on apply. Okay, so this is how our shaft looks like. So now what do we need? Okay, let me bring back my pulley. So now what do we need? We need a spacer and a gland and a gear, but we can put the gear first. Guys, I just want to make sure that I complete this exercise, guys. But we're only left with 3 parts now. 10 more minutes. Sorry, guys. It's too much. It's too much. It's too much. Oh, what's happening? All right, guys, let's come back. So now I'm saying that we need the what now? We need the gear. And guys, remember, when we are not given now the final assembly, you just have to work with the dimensions. That's what you are working with. Because here we knew that a 19 of this shaft has to go to a 19 of this pulley. A 38 of this push has to go to a 38 of this bracket, and also considering the length, that okay, the length, it has to be 32 and 32. Even here we did consider this length, that it has to be whatever length it is, but it has to correspond with this one. Okay, so even here this is still diameter 24, and even this one on the bracket 4. So you are just working with dimensions. If you don't have if you are not given the assembled drawing. Okay, so as you can see, guys, I'm also working with what I gave you. There's no assembly here, but then I'm just working with dimensions. Okay, now what's next is this gear, and we know that this is diameter 19, right? And where is another diameter 19? Here, this shaft, it's diameter 19. Okay, let's place. Let's withdraw this one so we can find it here. Okay, there is our gear wheel, guys. Oh, sorry. Okay, so you see what happened. I placed 3 gears, right? But you can only see one. Why is that the case? It's because the others, I placed them this side in front of this cut section. So if they are here, I can't see them. So this one, I can't see it. So I might as well just delete it. Even this one, I can't see it, delete, and then work with that one. Okay. So we constrain and we insert. We're saying that a diameter 19 has to go to another diameter 19, like that. And even this length, it has to correspond. From here to here should be the same as from here to there, right? Cancel. So there you have your gear. And then
Sorry.
Yes.
Since this thing has got a keyway, shouldn't the shaft have a key?
Yes, the shaft is supposed to have a key or a keyway, key slot. Yes, it's supposed to. But then I didn't want to give that to you guys, like just to save your time, because I don't think in the test you'll be drawing keys and keyways.
Okay, thank you.
Yes. Okay, so yeah, this now we have our gear looking like that. So now you can see that we're missing what nuts here. We need a nut here, this end, even at this end. Okay. And now coming back here, we are told that the nut, okay, I even omitted some information, guys. I was supposed to tell you that it's hexagonal nut, okay? So, but then now I did specify which nut do you want. It's ISO 403 and it's an M16 nut. So it being M16 tells you that it has to come here because this shaft it's M16 here, okay? So now that's where now content center comes in, guys. You don't have to draw that nut, you just have to get it from content center. And how do you do that? You go to place. But then now you drop down and then place from content center. Okay, yeah, so this is what you will get. What is it that you want from content center? Okay, let me just make it default. Yeah, this is what you're gonna get. And then you go to fasteners and then nuts, right? And then what type of a nut do you want? You want a hexagonal nut. But then now there are many. There are DIN, there are ANSI, of which we only want in what? In ISO. So now that's where you come to this filter here, and then you say ISO. So now the nuts that are showing are only the one that are using ISO standards. Okay, and then this one, it was specified that it's ISO 4032. Okay, ISO 4032, and then you come here, there is ISO 4032, and then okay. And then you just right click, you change size, okay? And then what size do you want? Want an M16, right? So you can see you have many of them. You have about M10, M12, M14, but then in this case, want an M16. So you can come here to check the thread. Lucky enough, the thread is M16 by 2, which corresponds to our shaft, which is also M16 by 2. And then you click on apply, and then okay, wait for it to load. I didn't place it. Oh, there it is, guys, sorry. Then you just place and you place and then click on OK. Okay, cancel, and then cancel again. But then now, guys, this nut, as much as it is the part of our assembly, but it is not here. It is not here in our folder where we saved our parts. Now I don't know what's happening. You see, it's not here, that nut. So now how do you take it to this folder where you have all your other parts? You come here. This is the nut, right? And then you right click here and then open file location, right? Okay, let's wait for it. So this is where our nut is, but then want to take it to where the rest of our parts are. So you can just cut it from here and then go back to where your other files are and then just paste it, right? Let's wait. So now here you have your nut with the rest of your parts. So you're good to go, right? So now let's insert our nut. We know this is M16, so that this is diameter 16, which has to go to another diameter 16, which is this one, and there you have it like that. Apply, and also the second one to another M16, and there you have it like that. Okay, all right, so now we're missing 3 components: spacer, gland, and the stud. Okay, let's place the spacer first. There we have it, and then we know that it has to come here, right? It has to come here, and we know that this outer diameter, it's diameter 38, and even this diameter here is diameter 38, so a 38 to a 38, and then this smaller diameter, it's 24, even this one here, it's 24, so a 24 to a 24. Constrain, insert, want to insert a 24 to another 24, just like that. Apply, just like that. There you have your spacer there. Okay, what else? It's a gland, right? There we have it. Okay, so these colors are the same, but it's not much of a problem. Okay, let's place a gland. We know this is diameter 24, and also this is diameter 24, so a 24 to a 24. Constrain, insert a 24 to another 24, and then you just have to reverse the direction. Cancel. Let's see, we're saying that we want to constrain this 24 to this 24 like that, but then you have to flip the direction. Yes, just like that. Right, so there you have your gland there, right? So it fits perfectly there. Okay, so you can see that it's rotating and all of that, but then we don't want it to rotate. Want to align it, want to align this hole to that one. And how do we do that now? We come to our gland. We need the horizontal plane, which is XZ plane. Let's see, this one, it's YZ, and then just make it visible. And then let's also go to our bracket again. Within there we need this horizontal plane, make it visible, right? By doing that, we're trying to align this hole to that hole so that our gland will stop doing this. You see, don't want this. Okay, so assembly design, no, sorry, assembly constraint, insert, not insert, mate. Remember, it's not a circular part now, so it's a mate constraint. Want this plane to be parallel to this plane, just like that. Click on apply, and then there you have it. So now your gland is no longer moving, so you're good to go. So again, you don't need this, you also don't need this. Okay, what are we missing? We're missing a stud. So where does that stud go? It goes here all the way to there, right? So now let's place our stud. Here's our stud. Okay, and then we need 2 of them. Okay, because you were told that the quantity that there are 2, so the studs here, it's 2 of them. Even for those nuts, it's 2 of them. Okay, so what you have to know about this is that from here to here, it's 19. Can you see that? And now coming to our bracket, even this hole, it's 19 millimeters deep, meaning that that 19 has to go all the way here, right? So constrain, insert, the shorter side is the one of 19, which is this side. So this, and remember this is it's M10. Even this hole it's M10. So even this one is M10, right? So it has to go all the way in there, just like that. Click on apply, cancel. And guys, I hope that you can see that all my relationships don't give me errors. Okay, so again, let's insert another 16, another M10 to another 10. So it has to be this other. Okay, I mean that now we need to delete the half section view, guys. Okay, because we need this hole now. So we need to insert this to this, then done. Okay, as you can see that something happening here. You see, it doesn't fit perfectly. It's because this hole is diameter 11, but then the start is M10, so it's diameter 10 and diameter 11. So yeah. So guys, this is what your assembly was supposed to look like this. Sorry guys. All right, yeah guys, so this is how your assembly is supposed to look like that. Okay, so now what's next? We saved our assembly before starting assembling, right? So now since you're done assembling, you just have to save again. Just click there to save, and then yes to all. Okay, and okay, our session is supposed to end now, guys. But then you guys have challenges with the what you call it, balloons, part list, and also what else, sectioning. Okay, so I don't know, for the sake of those who didn't attend, we can add 10 more minutes because at 1:15 it will stop recording. So even though the meeting may continue, but the recording will stop. So let's see. I just hope you don't kick me out, guys. It's already almost 1:15. Guys, it's try. it's try. Yeah, the meeting ended. So those who are not here, they are lost. They won't see the what? They won't see the recording. Okay. All right. DWG file, guys. DWG file. No, guys. What happened to my inventor now? All right, the DWG file, guys. Okay, so we saved our assembly. We don't have to stress about anything because here in our folder, there we have it, our assembly. Okay. Okay, so now let's create a new file again. Then what type of a file do we want now? We want a DWG file, ISO DWG. And then you create. But guys, I just hope that no one will struggle drawing an oil hole in the test, guys. That one, I think I explained it. Guys. What you need to know is that you just need a plane that will be tangent to your surface, right? So how do you get that? You just need a point on your original sketch, and then you go to 3D model, plane, and then tangent to a surface through a point, and then you're good to go. Okay, DWG. Let's place our views. Okay, before any of that, you have to save first. You have to save, guys. Otherwise, you'll be crying when you have to submit, saying that you can't save your work. You see? So, we built assembly. So before you do anything, you just have to save, guys, before you do anything else. Okay, so it's still saving. Now let's place. Oh, still saving, sorry. Oh, but then guys, since I didn't draw the stud and the gland, you didn't have any challenges drawing those ones. Because now I just assumed that you guys can draw them. Since I didn't show you guys, were you guys able to draw them?
Yes.
Okay, I get a yes. But by show of hands, guys, you can just raise your not hands, the thumb thing, the like thing, so that I can see if you guys are able to draw. Okay. Seems like people were able to draw. Okay. By the way, those were the easiest parts. Those ones, they were easy. Okay, what's happening here? You have your tutor here, so everything is okay. All right, let's go back. Again, in your assembly, in your DWG file, you need your 3 views according to first angle or third angle projection. It's up to you. So I always use third angle, so which is front left and top, right? Okay. So let's place. So this one is my front view, okay, but let me place my left, right? No, not my left actually. What I'm saying is I want this one to be my front, this one. I want it to be my front. Then okay. So now I need what? Okay, I need a top view. Top view of this. It's gonna be like that. What else do I need? I need a sectional front view, not just any front view, but a sectional front view. So just in case you get an instruction to produce a sectional view, so I want a sectional front view. Otherwise, I could have just projected this to here, right? Okay, it's fine. I have my front view. but it's not sectioned. Okay, undo. So now let's section. We want a sectional front view, right? So let's section. Which part do we want to section? We can say we want to section this this view, because if we were to section it, how will you section it? Okay, it's fine. You can section it like this, right? And then click on continue. And then what? It goes like that. Even this one, it's okay. But then, like I told you, it depends on your projection. Are you using first angle or third angle? So I believe, which angle is this one? I don't know. Okay, since I want first angle, so I have to section this one, because I already have my front, I already have my top, but now I want my left. Okay, I want to section this one in the middle like that, and then continue. And there I have my sectional front view looking like that. Okay, this one you can always play around. Let's delete this. Like it doesn't have to always be a what a half view. It can also be, it doesn't have to always be a half sectional view. It can be a quarter section. Okay, so how do you go about a quarter section? You just have to go like this, and then you get here, now you go like that, and then that's it. Sorry, I'm saying now for a quarter section, right? You go down the middle and you also go down that side, and then now you have a quarter section view, not a half section. So this one is a quarter, the one here initially was half section. So the choice is yours. Okay, you don't want your shaft to be sectioned, you just right click and you hide. And there you have it, like that. And then, okay, I don't need this view, this one. I don't need it because now it will cover more space, of which we need the part list here, right? Okay, so we don't need this view, we can delete it. And let's drag this one. Now, how do you create a part list? You go to annotate, part list, and then now it will ask you the file that you want to create a part list of. So it's either you go here and select the file, or to make things easier for you, you see now I'm going to select the file from where I saved my work. I'm saying that I want a part list of this file. Okay, and then click on OK. You see, just like that. You see, but then that one is a long way. That one is a long way. You just come here, part list, and then you just click here on this select view. You want a part list of this, that's all. And then click on OK, and there we have it, right? There is your part list, guys. Okay, so here is the description. Now it says that this ISO 4032, it's a hexagonal nut. Okay, so it's up to you if you keep this or you don't. If you don't want to, because we need the material, we need to see that are you guys able to select the correct materials. So since the material were assigned, we need to see that were you guys able to also assign them. So now we just have to double click here. No, not left, right. Left, right, left click twice, yes. And then you come here to this column chooser, and we don't want the description, you remove it. We want what? Material. You edit, and then click on OK. Apply, cancel. So there there's your part list. Now it has what? It has the material column. It no longer has the description column. All right. Now what's next? Balloons. And for balloons, what I always tell you is that look for the view that shows all your components. Because now looking at this front view, the only component that you can see is the pulley, the shaft, and the nut. Can you see the rest? No. Coming here, on this one, you can't see the spacer because it's inside here. So again, you can't use this view for balloons. And now let's come here. Here we can see everything, even the start, we can see it, there it is. There is the gland, there is the spacer, there is the bracket, there is a gear, there is a nut, a shaft, a bush, and a pulley. I'm not so sure if this one should be sectioned. I don't know, but I doubt. Okay, so meaning that this is the perfect view for you to place your balloons. So now, how do you place balloons? You come here to balloon, and then you drop down, and then you say auto balloon. Okay, and then you can see here that it's on select view set. Which view do you want to balloon? This is the view that I want to balloon. Which components do I want? So this add or remove, which means that which components do I want? And then you just highlight because you want all of them. And then now, how would you like to place your balloons? Around, vertical, horizontal, it's up to you. So this is horizontal, but let's place them around like that. And then click on apply, cancel. There you have your balloons. Okay, let's remove this, guys. Okay, and then now after that you can arrange your balloons, place them properly by just going to a balloon and then drag. Okay, let's say this one we want to place it here, and then this one we want to place it up there, that one there, and this one here. Yeah, but for a nice representation, guys, yeah, you can always drag this and place them where you want to place them. Okay, like that. So that's how you create balloons and the part list with the materials. So guys, from the questions that we asked we asked on the group that what do you need assistance with, and then you said that you need assistance in creating oil holes. I illustrated that. And then you also said you need assistance in creating a part list. That's what we just did. You need assistance in creating balloons. We did that. And what else? Saving your files. I did that. But then we're still missing one thing, creating a zip folder. Okay. So let's see. Let's come back here. It's gonna take longer, but I just wanna say something here. So this is the only thing that we haven't done. So we did this one of assigning material, we did use constraints, we did place from content center, we did create part list, we did create a sectional view, we did create balloons, we did save IPT files and assembly files in the DWG. So now the only thing that is missing is how to create a zip folder. Okay, so remember you saved this before. Okay, let's say I were to just close this without saving. All right, so if I close this, it asks me that, do I want to save changes to this assembly? If you click no, then that's on you, because you have to start afresh. Remember, we saved this before placing all of this. So if you say no, you will have to start afresh. And then yes, I want to save the changes. Okay, yes to all, and then okay. So guys, please just make sure that whenever you are closing your drawings, check on that pop-up, because if you say no and then now you have to start afresh. Okay, so now let's go back to our folder. Here we have all the parts here, guys. Okay, and let's do it like this, and like that. And like that. It's taking longer now, I don't know. And guys, for your test 2, please do that exercise, the other 2 I sent you, the one of crane hook. Please do it, guys, and also revisit that stuffing box. Okay, all right, so this is our folder, right, that has our parts, right? You can always double check. So yeah, here are all your files, your part files, your assembly, and your DWG. So we need the lecturers, they need all of these parts, these files, in order to mark your work. Okay, so okay, we did double check. So now what you have to do now, we are preparing a file that you are going to submit. So you come to this folder and then you right click, and then you click on, okay, what's happening? You see, this was 11 things of yours, guys. You right click, okay, there at the computer lab, it won't show this, it will show send to. So since this is Windows 11, it doesn't show that send to option, so compress to a zip file. Okay, and there I have my zip file there. Okay, but then there in the labs, guys, you just click here and then you will see an option that says send to. So you click on that one and then compressed zip folder. Yeah, that's how it will show there. So since this one is Windows 11, so it's not showing like that. So here is my zip folder. Okay, so this zip folder, it has to have everything inside, right? Here it has the parts, it has the assembly, it has the DWG. So this is the file that I'm going to submit. This one, not that one, this one, with everything inside. Okay, and then any questions, guys? Okay, before that, we'll just let's do this. I will share this PDF file with you guys in the group. Okay, let's wait a bit. Okay, so I'll share this with you guys in the group, like just in case you were lost somehow, so that you want to see how your assembly is supposed to look like and how your parts align to each other. So I didn't send you this one because you guys, you said you don't want a final assembly, you just want parts, right? So I gave you the parts and this is what you have to produce. Okay. With that being said, guys, now I'm back to attend questions. Yeah, questions, guys, questions. No, guys, you can't be quiet. You can't. When you are writing on Friday. No, guys. I'm writing on Friday or next week. I don't even know your test dates. When are you writing, guys? Friday?
Yeah, it's Friday.
Okay. I mean that then, guys, we're not ending this session without questions because you can't be quiet when you are writing on this day. On Friday, sorry. And I gave you this exercise to attempt, but then the only issue was with the bracket. So all of you guys only struggled with the bracket. Nothing else. Only the brackets and then oil hole. And what else? And us guys as your tutors, we can't do our work when we don't know your struggles. We can't. Because we can't think for you that, okay, maybe now the students are lacking on this and that. No, guys, we can't. We need to hear from you. The platform is open, guys. You can unmute yourself or you can type in the chat box. It's up to you. So we're listening, guys. You are too many here, guys. 50 of you, but don't have questions. No, guys. So are there any of you who want to go back on this session so that you can watch later? Do you want to watch later? Or like just for reference, maybe for certain things, or you guys are fine? Because I think the file will be too large for me to share, guys. Let's see. It's been recording for 3 hours. No. So now I'm stopping the recording and but I don't think this time around I'll share it on YouTube because the file is very big, guys. I will just share the link, the one that what link? Yeah, I'll share the link, the one near Teams, yeah, Microsoft Teams. Yeah, so you'll be able to access the recording there because I think the file is too large for YouTube, guys. Okay, so there's a hand. You can unmute yourself. Then
Say, how are you?
I'm okay. Say, how are you?
I'm good. I want to ask what's your YouTube channel? I'm attending on the other group that is at